Exam number 4. Review questions. Okay, so on section 8.1, page 482, problem number 20. Use the square root property to solve each equation. 3p squared plus 36 equals 0. Let me subtract 36 from both sides of my equation. Divide by 3. So you have p squared equals negative 12. Therefore, by the square root property, p is equal to plus or minus the square root of negative 12. I can write negative 12 as the product of negative 4 and 3, the largest perfect square factor of 12. The square root of a negative 4 is 2i. Therefore, p is equal to plus or minus 2i radical 3. Let me do problem number 26. Y minus 4 quantity squared plus 18 equals 0. So let me solve that. So first let me subtract 18 from both sides of my equation. And so I have that y minus 4 squared equals negative 18. By the square root property, I have that y minus 4 is equal to plus or minus the square root of negative 18. Let me write negative 18 as negative 9 times 2. And so I have that y minus 4 is equal to the square root of negative 9 is 3i radical 2. And so let me add 4 to both sides of my equation. So y is equal to 4 plus or minus 3i rad 2. And that is your answer. Let me do problem number 42. Solve each equation by completing the square. X squared minus 6x plus 3 equals 0. Subtract 3 from both sides of your equation in order to have all x's on one side of your equation and no constant terms on the left side of the equation. So now, since there's a 1 in front of the x squared, I'll take negative 6 divided by 2 is negative 3. Square that. Negative 3 squared is 9. And let me add 9 to both sides of my equation. And so now, the left-hand side of my equation is just a perfect square trinomial. So I can factor that as x minus 3 quantity squared. 9 minus 3 is 6. And so, by the square root property, I have that x minus 3 equals plus or minus the square root of 6. Add 3 to both sides of your equation. And so I have that x is equal to 3 plus or minus rad 6. And that is your answer. Okay, so let me go on to section 8.2, page 492. Let me do problem number 14. Use a quadratic formula to solve each equation. 1/6 x squared plus x plus 1/3 equals 0. Well, If I'm going to plug into a formula, I might as well make the equation as simple as possible. So let me multiply both sides of my equation by 6. So I get x squared plus 6x plus 2 equals 0. 6 divided by 3 is 2. So now this equation is much easier than no fractions. There's just a whole bunch of whole numbers, coefficients here. So now the quadratic formula says that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And so x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And so negative 6 plus or minus the square root of 6 squared is 36. 4 times 1 times 2 is 8. 2 times 1 is 2. And so 36 minus 8 is 28. Let me rewrite 28 as 4 times 7. The square root of 4 is 2. I can factor a 2 for the numerator, and so I get a negative 3 plus or minus rad 7 over 2. So now that I've written this as a product, I can cancel the factors. And so I get x is equal to a negative 3 plus or minus rad 7. And that is your answer. Let me do problem number 26. X plus 6 plus is equal to 2. So let me multiply the x inside the parentheses. X squared plus 6x is equal to 2. Subtract 2 from both sides of my equation. And so I have x squared plus 6x minus 2 equals 0. Now that I've done this, I can now use the quadratic formula to solve this. And so I have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so b is equal to, is that the same equation? No. And so b is equal to, x is equal to a negative b plus or minus the square root of b squared minus 4ac all over 2a. And so x is equal to negative 6 plus or minus the square root of 6 squared is 36. A negative 4 times 1 times negative 2 is a positive 8. All divided by 2 times 1, which is 2. 36 plus 8 is 44. Let me rewrite 44 as 4 times 11. The square root of 4 is 2. Let me factor. And so x is equal to, I can factor out a 2 that's in common in the numerator, negative 3 plus or minus rad 11 over 2. I can cancel the common factor here. And so I have here x is equal to negative 3 plus or minus rad 11. And that is your answer. Let me do problem number 32. So problem 32 says 3y squared plus 6y plus 5 equals 0. Okay, so let me use the quadratic formula to solve that equation. And so x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And so x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And so x is equal to negative 6 plus or minus the square root of 6 squared, 36. Negative 4 times 3 times 5, 60. All divided by 2 times 3, 6. So x is equal to negative 6 plus or minus the square root of, well, 36 minus 60, negative 24. Let me rewrite 24. Negative 24 as negative 4 times 6. And so I have that x is equal to a negative 6 plus or minus the square root, square root of negative 4 is 2i rad 6 over 6. I can factor out 2 from the numerator. So 2 times negative 3 plus or minus I rad 6 over 6. Let me cancel. So 6 divided by 2 is 3. And so x is equal to a negative 3 plus or minus I rad 6 over 3. And that is your answer. Let me do problem number 54. The hypotenuse of an isosceles right triangle. So you have here an isosceles right triangle. So you have a right triangle and it's isosceles, so each of these have the same length, is, and they're in meters, I guess. So the hypotenuse of an isosceles right triangle is 1 meter longer than either of its legs. So this is going to be 1 meter longer than either of its two legs. Find the length of each side. Okay, well, by Pythagorean's theorem, a squared plus b squared equals c squared. And so a squared plus b squared equals c squared. Well, 1x squared plus 1x squared is 2x squared. By the special product formula, I have that x plus 1 quantity squared is just x squared plus, well, x times 1 times 2 is 2x, plus 1 squared is 1. Subtract x squared, 2x, 1 from both sides of your equation, so that the right-hand side of your equation becomes 0. So I have x squared minus 2x minus 1 is 0. And, well, I really can't factor this, so why don't I use the quadratic formula? X equal negative b plus or minus square root of b squared minus 4ac all over 2a. And so I have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to 2 plus or minus the square root of negative 2 squared is 4. Negative 4 times 1 times negative 1 is 4. 4 plus 4 is 8. I can write 8 as 4 times 2. The square root of 4 is 2. I can factor 2 from the numerator. Oops. Factoring 2 from the numerator. I get 2 times 1 plus or minus rad 2 over 2. I can cancel. And so x is equal to 1 plus or minus rad 2. Now, 1 minus rad 2 is negative. And so I do not want a negative length. And so x is equal to 1 plus rad 2. Therefore, my triangle has a leg of 1 plus rad 2 meters. Your other leg is, well, the same length, 1 plus rad 2 meters. And, well, if you add 1 to 1, you get 2. And so the other, the hypotenuse, has a length of 2 plus rad 2 meters. Okay. So let's go on to section 8.3. And so on page 501, let's do problem number 22. And so I have here solve m minus 6 squared plus 5 m minus 6 plus 4 equals 0. So this is quadratic in m minus 6. I can actually even factor this. So why don't I factor this? This is actually monic, a monic quadratic in m minus 6. I want to find, so I have here a plus. I'll bring down the plus. Times plus is plus. I want to find two whole numbers whose product is 4 and whose sum is 5. 4 and 1. And now let me just simplify this. M minus 6 plus 4 is m minus 2. M minus 6 plus 1 is m minus 5. Set each factor to 0 and solve for m. So m minus 2 is 0, or m minus 5 equals 0. Let me add 2 to both sides of my equation. Let me add 5 to both sides of my equation. And so m is equal to 2, m is equal to 5. And that is your solution. Let me do problem number 38. X to the power 2/3 minus 2x to the power 1/3 minus 8 is 0. Well, again, this is quadratic in x to the 1/3. You can factor this. This is a monic quadratic trinomial. And so x to the 1/3, x to the 1/3. Let me bring down the minus, times minus is plus. I want two whole numbers whose product is 8 and whose difference is 2. Well, 4 and 2. I'll put the larger first. So 4, 2. And so set each factor to 0 and solve for x. X to the 1/3 minus 4 equals 0. Or x to the 1/3 plus 2 equals 0. Add 4 to both sides of your equation. Subtract 2 from both sides of your equation. And so x to the 1/3 is 4. Cube both sides of your equation. So x is equal to 64. Subtract 2 from both sides of your equation. So x to the 1/3 is a negative 2. Cube both sides of your equation to solve for x. So x is equal to So x is equal to negative 8. And that is your answer. Let me do problem number 44. Y to the negative 2 minus 8y to the negative 1 plus 7 is 0. This again is quadratic in y to the negative 1. It's monic and quadratic. And so I can see if I can try to factor this. So y to the negative 1, y to the negative 1. Let me drop down the minus, and then times plus is another minus. So these are minuses. I want two whole numbers whose product is 7 and whose sum is 8. Well, 7 and 1. Set each factor to 0 and solve for y. Y to the negative 1 minus 7 is 0. Or y to the negative 1 minus 1 is 0. Add 7 to both sides of your equation and solve for y. And so y to the negative 1 equals 7. And so so let's just take the reciprocal of both sides of my equation. And so y is equal to 1 over 7. And of course, you're not dividing by 0 if y is equal to 1 over 7. You'd only be dividing by 0 if y were equal to 0. Add 1 to both sides of your equation. So y to the negative 1 equals 1. Let me raise each of these to the power negative 1. So y is equal to, well, the reciprocal of 1 is just 1. And again, you're not dividing by 0. Okay, so that finishes off section 8.3. Let's go on to section 8.4, page 510. Let me do problem number 10. Solve each inequality. Write the solution set in interval notation. X minus 6 times x minus 4 times x minus 2 is less than or equal to 0. And so this is in factored standard form. Let me determine my critical numbers. I can determine my critical numbers by setting each factor to 0 and solve for x. Add 6 to both sides of your equation. Add 4. Add 2. So x is equal to 6, x is equal to 4, x is equal to 2. So those are my critical numbers. Let me place those critical numbers on my number line. So I have here 2, 4, 6. Let me take a number less than 2, 0. So when x is 0, x minus 6 is negative, x minus 4 is negative, x minus 2 is negative. Negative times negative times negative is negative. The root at 2 is simple. It has a multiplicity of 1, which is odd. Therefore, this alternates in sign to positive. The root at 4 is simple. It has multiplicity of 1, and so it alternates in sign. It has odd multiplicity. The root at 6, again, has a multiplicity of 1, which is odd. Therefore, it alternates in sign. We want this to be less than or equal to 0. Since we want it to be less than 0, we fill in any of these that have negative. And so I'll fill in the negatives. Okay. And we want it to be less than or equal to, so I'll fill in every critical number where the expression is defined, and it's defined everywhere. So I'll fill in every critical number. Therefore, my answer is the interval, closed interval, from negative infinity to 2, union the closed interval from 4 to 6. And so that is our solution. Let me do problem number 20. X plus 1 over x minus 4 less than or equal to 0. So let's determine this is already in factored standard form. So let me determine my critical numbers. I can determine my critical numbers by setting each factor to 0, x plus 1 to 0, x minus 4 to 0. Subtract 1 from both sides of your equation. Add 4 to both sides of your equation. And so I have x equal negative 1, x equals positive 4. Let me place those on my number line. When x is 0, x plus 1 is positive. X minus 4 is negative. Positive divided by negative is negative. So let me fill this in as put in a negative sign there. The multiplicity of the root at 4 is 1, which is odd. Therefore, it alternates in sign. The multiplicity of the root at negative 1 is also odd. It's multiplicity of 1, so it alternates in sign. And so we want this to be less than 0. So let's fill in the negative. We want this to be less than or equal to 0. And so we'll fill in those critical numbers except for, so I'll fill in every critical number except for those critical numbers where the expression is not defined. This expression is not defined when x is equal to 4, because if x were equal to 4, then you would be dividing by 0. And so you don't want to divide by 0. So I'll fill in the negative 1, but I'll keep the value at 4 open. So this is actually a half open, half closed interval from negative 1 to positive 4. And that is your answer. Let me do problem number 24. y squared plus 15 over 8y is less than or equal to 1. Okay? And so, this is not in standard form. So let me subtract 1 from both sides of my inequality. So I have here y squared plus 15 over 8y minus 1 is less than or equal to 0. Well, let me get a common denominator. The common denominator is 8y. So let me multiply and divide by 8y. So I have y squared plus 15 over 8y minus 8y over 8y less than or equal to 0. And so, adding numerators, I get y squared minus 8y plus 15 all over 8y is less than or equal to 0. I can factor the numerator. This is a monic polynomial, monic quadratic. I have a minus, so I'll bring down the minus. Times plus is minus. I want two whole numbers whose product is 15 and whose sum is 8, 5, 3. So now I've written this in factored standard form. And so let me determine my critical numbers. Set each factor to 0 and solve for y. Y minus 5, 0. Y minus 3, 0. 8y, 0. Add 5. Add 3. Divide by 8. And so y is equal to 5. Y is equal to 3. Y is equal to 0. And let me put those on my number line. And so I have here 0, 3, 5. Let's take a number greater than 5. Let's say 6. If I replace y by 6, this is positive, positive, positive. Positive times positive divided by positive is positive. The multiplicity of the root at 5 is 1, which is odd, so alternating sign. The multiplicity of the root at 3 is odd, 1, so alternating sign. The multiplicity of the root at 0 is 1, which is odd, so alternating sign. We want this to be less than 0, so I'll fill in the negative. And I want this to be less than or equal to, so I'll fill in every critical number except for those critical numbers where the expression is not defined. This expression is not defined when you divide by 0, when y is 0. So y equaling 0 will not be filled in, but all other critical numbers, 3 and 5, will be filled in. And so my answer is the open interval, negative infinity to 0, union the closed interval, 3 to 5. And that is your answer. That finishes section 8. No, it doesn't. Let's do problem number 46. X minus 2, x plus 2 over x plus 1, x minus 4, less than or equal to 0. So this is in factored standard form. So let's determine my critical numbers. So let me set each factor to 0 and solve for x. X minus 2 equals 0. X plus 2 equals 0. X plus 1 equals 0. X minus 4 equals 0. Let me add 2, subtract 2, subtract 1, add 4. So I get x equals 2, x equals negative 2, x equals negative 1, x equals positive 4. Let me place those on my number line. So negative 2, negative 1, 2, 4. Take a number between negative 1 and 2, let's say 0. When x is 0, this is negative, positive, positive, negative. And so negative times positive divided by positive times negative is positive. The root at 2 has multiplicity of 1, and so it's odd multiplicity, so it alternates in sign. The root at 4 has a multiplicity of 1, odd multiplicities, alternates in sign. The root at negative 1 has a multiplicity of 1, odd, so alternates in sign. The root at negative 2 has odd multiplicity, so it alternates in sign. We want this to be, again, less than 0. And so let's fill in anything below the minus. And we want to be less than or equal to 0. So we'll fill in every critical number except for those for which this expression is undefined. It's not defined at negative 1. It's not defined at 4, because at those points you'd be dividing by 0. But it is defined everywhere else, so let's fill in all those other critical numbers. Therefore, your answer is just the union of the half open, half closed intervals. And that is your answer. So that finishes off section 8.4. Let's go to 8.5, page 519. Problem number 26. G of x equals 4x minus 4 squared plus 2. Okay, so sketch the graph of each quadratic, label vertex, and the axis of symmetry. Okay, so let's do that. So first, let's determine the axis of symmetry. Axis of symmetry is found by setting what's inside the square equal to 0. So the axis of symmetry is just x equals 4. The vertex has an x-coordinate the same as the axis of symmetry. You can determine the y-coordinate of the vertex by just plugging in 4. 4 minus 4 is 0, squared is 0, times 4 is 0, plus 2 is 2. Therefore, the vertex is at 4, 2. A, the number in front of the square term, is 4, which is greater than 0. Therefore, this parabola points up. A is greater than 1. It's equal to 4. And so, since this A is greater than 1, then you're going to be stretching the y-axis by a factor of 4. And so If you look at the graph of y equal x squared, you sort of stretched it. And so it becomes this elongated, thin sort of graph as compared to the graph of y equal x squared. And so let me graph this. And so the vertex is at 4, 2. It points up, and it's relatively thin. It should be symmetric, but... And so the axis of symmetry is the line x equal 4, and the vertex is at the point 4, 2. Let me make it a little bit more symmetric if I can. Let's try this again. Now the other side doesn't look as good. Okay, let's try this again. It's not as bad. It's actually not too bad. Okay, that looks now that looks pretty good. Okay, so this is the graph of y equals 4x minus 4 squared plus 2. Okay, let me do problem number 28. F of x equals negative x minus 2 squared minus 6. So let me determine the axis of symmetry. So the axis of symmetry found by setting what's inside the square equal to 0, x equals 2. And that's the equation of the axis of symmetry. The vertex has x coordinate equal to 2. Let's determine the y coordinate by plugging in for x 2. Well, 2 minus 2 is 0. Squared is 0. The opposite of 0 is 0. Minus 6 is negative 6. So your vertex is at negative 6. The coefficient in front of the square term is negative 1, which is less than 0, which means that this points down. A in absolute value is just 1. And so that means that this actually has the same shape as the graph of y equal x squared. So let's try to draw this. Okay. 1, 2, 3, 4, 5, 6. Okay, so the vertex is at 2, negative 6. Has the same graph, same shape. So it will look something like That doesn't look too bad. Yeah, good enough. So this is, the vertex is at 2, -6. Axis-symmetry, x equals 2. And so I've sketched the graph of y equal -x minus 2 squared minus 6. Let me do problem 24. 24, f of x equals x squared plus 2x minus 3. Find the vertex of the graph of each quadratic. Oh, I guess this is section 8.6 now. So, yeah, section 8.6. So page 526, section 8.6. Let me do problem 24. F of x equals x squared plus 2x minus 3. Find the vertex of the graph of each quadratic function. Determine whether the graph opens upward or downward. Find any intercepts and sketch the graph. Okay, so let's do that. Let's find the vertex. Well, actually, let's find the axis symmetry first. And so the formula for the axis symmetry is x is equal to a negative b over 2a. And so I have here x is equal to a negative b over 2a. The 2's cancel, so x is equal to negative 1. So the equation for my axis of symmetry is x equal negative 1. Let's determine the vertex. Well, to determine the vertex, I know that the x-coordinate of the vertex is negative 1. Let's determine the y-coordinate of the vertex by plugging in for x, negative 1. So negative 1 squared plus 2 times negative 1 minus 3. So that's going to equal 1 minus 2 minus 3, which is a negative 4. So my vertex is at negative 1, negative 4. Let me determine a. So a, the coefficient in front of x squared is 1. It's greater than 0. So it's going to point upward. As a matter of fact, since a is 1, it will have the same shape as the graph of y equal x squared. Let's determine the intercepts. And so first let's determine the x-intercepts. Determine the x-intercepts. I'll just set the y equal to 0. So x squared plus 2x minus 3 equal to 0. And, well, in this case, actually, I can factor this. This is a nice monic quadratic. I have a plus times minus is minus. I want to find two whole numbers whose product is 3 and whose difference is 2. 3 and 1. And so, let's set each factor to 0 and solve for x. Subtract 3. add 1. So x equals negative 3, x equals 1. Therefore, the intercepts are at negative 3, 0, 1, 0. And let's find the y-intercepts. So the y-intercept is found by just, this is f of x, right? Yeah, f of x. Just plugging in 0 for x and determining your corresponding y value. Well, 0 plus 0 minus 3 is negative 3. Therefore, my y-intercept is at 0, negative 3. Oh, okay. And so I can use all of this now to sketch the graph. So let me try to do it here. Oh, negative 1, negative 4. So the intercept is at negative 1, negative 4, and 1. I have an intercept here, y-intercept, and a y-intercept here, and a y-intercept, x-intercept here. Okay. So let's see if I can sketch the graph of this, going through these points. Okay, did that one. Let's see if I can do the other one. Let's see if I can do the other side. Eh. Okay. That doesn't look too bad. Just make these a little bit bigger. Now everything looks perfect. Okay. So this is the graph of, what is it? Y equals x squared plus 2x minus 3. So let me label some of these. So the intercepts are at negative 3, positive 1, at negative 3, and the vertex is at negative 1, negative 4. And the symmetry is x equal negative 1. Okay, which now looks like a plus 1 because of that. So, negative 1. Okay. And so, I've done that problem. That was, well, problem 24. Let me do problem number 26. F of x equals negative x squared plus 4x plus 4. Okay, so let's do the same sort of thing. So let's find the axis of symmetry. And so x is equal to a negative b over 2a. So in this case, b is 4, a is negative 1. So the negatives cancel, and 4 divided by 2 is 2. And so I get here that x is equal to 2. That's my axis of symmetry. Let's determine my vertex. The x-coordinate of the vertex is 2. Let's determine the y-coordinate of the vertex. Negative 2 squared plus 4 times 2 plus 4. Negative 4 plus 8 plus 4 is 8. Okay. A is negative 1, and so that means that this is going to be pointing down. A is equal to 1. Therefore, this has the same shape as the graph of y equal x squared. Let's determine the x-intercepts. And so, let's try to set negative x squared plus 4x plus 4 equal to 0. Oh, that's not going to give us any nice intercepts. And so, I have here, matter of fact, it's 2, 8, and it's pointing down. Oh, so they will have some x-intercepts. And so let's use the quadratic formula. Actually, let me multiply by negative 1 first, so I don't have to divide by a negative before I plug this into the quadratic formula. And so I have here x squared minus 4x minus 4 is 0. And now let's plug into the quadratic formula. X equal negative b plus or minus square root b squared minus 4ac all over 2a. And so x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And so 4 plus or minus the square root of a negative 4 squared is 16. Minus 4 times 1 times negative 4 is 16 over 2. 16 plus 16 is 32. I can write 32 as 16 times 2. The square root of 16 is 4. Let me factor out actually just a 2 from the numerator. So that I can cancel the 2's. That's why I actually only factored out a 2, so I could cancel the 2's. So I get 2 plus or minus 2 rad 2. So therefore, the x-intercepts are 2 minus 2 rad 2, 0, and 2 plus 2 rad 2, 0. I mean, that's obviously not nice numbers. Okay. Actually, maybe I should box all of these, so they'll be easy to find. Let's find my y-intercept. And so, to find the y-intercept, you just replace x by 0 and solve for y. And so I get here a negative 0 squared plus 4 times 0 minus 4. 0 squared is 0. 4 times, and opposite of that, it's 0. 4 times 0 is 0, plus 0 is 0, minus 4 is negative 4. And so your y-intercept is at 0, negative 4. And so let's sketch the graph of this. So the vertex is at 2, 8. Well, maybe 2, 4, 6, 8. 2. Okay, it's at 2, 8. So I'm going in groups of 2s. So there, 2, 8. Okay, and x symmetry is 2, intercepts negative 4. Oh, wow, way down there. Okay. Vertex is at 2, 8. Yeah. Okay. Hmm. Well, try to do this, and then okay, good enough. Okay, so let's see. Oh, hmm. So the axis symmetry is x equals 2. The intercepts, all right, that's going to be negative 4. And this is going to be 2 plus 2 rad 2, wherever it is. And then this is 2 minus 2 rad 2, which is negative. Wait, this doesn't make sense. 2 minus 2 rad 2 is negative. One second. One second. There's something a little weird here. Wait 1 second. Okay, that looks good. X-intercepts. Two. Okay. 2 rad 2. That looks negative. Okay, I don't know why, but, well, I don't see the error offhand. Okay, so let's go on to Chapter 9, Section 9.1, page 540. Problem number 10. If f of x, so let me write these down, I guess. If f of x equal x squared minus 6x plus 2, g of x equals negative 2x, and h of x equals the square root of x. Let's do problem 10. Determine h composed with f at negative 2, which is h evaluated at f at negative 2. And so let's determine f at negative 2. Plug in for x, negative 2. And so negative 2 squared is 4. Negative 6 times negative 2 is 12. Plus 2 is 18. And now let's figure out h composed with f at negative 2 is h of f evaluate negative 2, which is h at 18, because f at negative 2 is 18. So let's figure out h at 18. Well, h is just the square root. So this is the square root of 18, which I can write as 9 times 2, and the square root of 9 is 3. So your answer is 3 rad 2. Let me do problem number 12. F composed with h at 1. So this is f evaluated at h of 1. But h is just a square root. So this is f evaluated at the square root of 1. But the square root of 1 is just 1. So let's plug in for x 1 in the formula for f. So it's 1 squared minus 6 times 1 plus 2. So 1 minus 6 plus 2 is equal to a negative 3. Let's do problem number 16. F of x equals x minus 3. G of x equals x squared. Find f composed with g. Wherever I see an x in the formula for f, I replace every x by the formula given by g. So wherever I see an x, I'll replace x by x squared. So x squared minus 3. Also determine g composed with f at x. So wherever I see an x in the formula for g, I replace x by the formula given by f. So wherever I see an x here, I replace x by x minus 3. And so this is x minus 3 squared. And that is your answer. Let me do problem number 20. F of x equals negative 4x. G of x equals x cubed plus x squared minus 6. Let's determine f composed with g at x. So wherever I see an x in the formula for f, I replace every x by the formula given by g. So wherever I see an x here, I replace x by x cubed plus x squared minus 6. So this is a negative 4, replacing x by x cubed plus x squared minus 6. Now, let me actually simplify this a little. Let me multiply the 4 inside. And so I get this is equal to a negative 4x cubed minus 4x squared plus 24. And that is your answer. Let me compute g composed with f at x. So wherever I see an x in the formula for g, I'll replace every x by the formula given by f. So wherever I see an x, I'll replace x by negative 4x. And so I get negative 4x cubed plus negative 4x squared minus 6. And that is your answer. You could simplify it if you want, but I'll just leave it in this form. Well, I'll put in both forms. Negative 4 cubed is negative 64, x cubed. Negative 4 squared is 16, x squared minus 6. So that finishes off section 9.1. Let me go on to section 9.2. Page, yes I did. Page 551, problem 34. Find the inverse of each one-to-one function. And so f of x equals x minus 3 over 2. So let's replace f of x by y. Multiply and now interchange x and y. And so x is equal to y minus 3 over 2. Multiply both sides of my equation by 2 so that I can solve for y. So let me get rid of the fractions. So 2x equals y minus 3. Add 3 to both sides of your equation. And so I have here that y is equal to 2x plus 3. And so finally, let's replace y by f inverse. So f inverse of x is equal to 2x plus 3. And that is your answer. Let me do problem number 38. F of x equals 7 over 2x plus 4. And so let's replace f of x by y. Let me interchange x and y. Let me solve for y. Multiply both sides of my equation by 2y plus 4. And so you get 2xy plus 4x is equal to 7. The 2y plus 4's cancel. Subtract 4x from both sides of your equation. So 2xy is equal to 7 minus 4x. Divide both sides of your equation by 2x. And so y is equal to 7 minus 4x over 2x. And lastly, let me write this as an inverse. And so f inverse of x is equal to 7 minus 4x over 2x. And that is your answer. Okay, so that finishes off section 9.2. Let's go on to section 9.3, page 559. Problem number 28. Solve each equation for x. 1 over 27 equals 3 to the 2x. So let me write 1 over 27 as 3 to the negative 3. So now, since the exponential function is 1 to 1, and since the bases are the same, then the exponents must be the same. So negative 3 must equal 2x. Divide both sides of your equation by 2. So I have that x is equal to a negative 3/2. And that is your answer. Let me do problem number 36. 4 to the power 3x minus 7 is equal to 32 to the power 2x. So let me first find a common base, 2. 2 squared is 4. 2 to the 4th is 32. 2 to the 5th is 32. 2, 4, 8, 16, 32. And so, let me use the laws of exponents to simplify this. A base to a power, well, you just keep the base and multiply exponents. 2 times 3x is 6x. 2 times 7 is 14. A base to a power, again, you just multiply exponents. 5 times 2x is 10x. Since the exponential function is 1 to 1, and since the bases are the same, then the exponents must be the same. Subtract 6x from both sides of your equation. Divide by 4. So x is equal to negative 14 divided by 4. I can divide both 14 and 4 by 2. So x is equal to a negative 7 over 2. And so that finishes off section 9.3. Let me do section 9.4 on page 564. Let me do problem number 18. The size of the rat population of a wharf area grows at a rate of 8% monthly. If there are 200 rats in January, find how many rats should be expected by next January. So, initially, the number of rats is 200. It grows by 8% every month. So, there are 8% additionally every month. 100% plus 8% is 108%. When written as a decimal is 1.08. After 1 year, let's find the number of rats. Well, there are 12 months in a year, and so I'll have to raise this to the power 12. And so let's multiply this out. And so 200 times 1.08 to the power 12 is 503. Well, this is your answer. And so the amount is approximately 503.634 0, 2, 3, 4, and it keeps going on for a little while. So this is what it is approximately. And so they're approximately 504 rats. And that's your answer. Okay. Let me do problem number 20. An accidental spill of 75 grams of a radioactive material in a local stream has led to the presence of radioactive debris decaying at a rate of 4% each day. Find how much debris still remains after 14 days. And so the amount is, well, you start out with 75 grams and 4% decay per day. Therefore, you start with 100%. You decay 4% of it. So 100% minus 4% is 96%. And so, written as a decimal, 0.96. So every day there's 96% of what you had the previous day. You want to figure out how much remains after 14 days. And so that's the amount. Let's plug this into a calculator to find its approximate amount. And so 75 times 0.96 to the power of 14 is 42. 42.35049843 grams. So it's approximately 42.35 grams. Okay. Let me do I guess that finishes off section 9.4. So section 9.5, page 572, problem number 8. Write each as an exponential equation. Log base 8 of y equals 7. So let's change this logarithmic form into a exponential form. The base is 8, the exponent is 7, and the result is y. Let me do problem number 22. Write each as a logarithmic equation. Pi to the 5 equals y. And so the base is pi, the result is y, and the exponent is 5. Problem 48. Solve log base 2 of x equals 3. So let's rewrite this in exponential form. The base is 2, exponent is 3, result is x. 2 cubed is 8. So x is equal to 8. Let me do problem number 60. Log base 2/3 of x is equal to 2. So let's rewrite this logarithmic expression, logarithmic form into exponential form. And so the base is 2/3, exponent is 2, result is x. 2 squared is 4, 3 squared is 9. So x is 4/9. That finishes off section 9.5. Let's do section 9.6, page 578. Problem number 8. Log base 6, 3 plus log base 6 x plus 4 plus log base 6, 5. Write each sum as a single logarithm. Assume variables represent positive numbers. And so this is equal to log base 6 of the product. Well, 3 times 5 is 15 times, well, x plus 4. Let me actually multiply the 15 inside the parentheses. And so, oops. So this is equal to log base 6 of 15x plus 60. And that is your answer. Let me do problem number 16. Log base 7 x plus 9 minus log base 7 x squared plus 10. And so write each difference as a single logarithm. Assume that variables represent positive numbers. And so this is the log base 7. Since x plus 9 is positive, the logarithm is positive, x plus 9 will be in the numerator. Since I'm subtracting, then I'll divide by x squared plus 10. And that is your answer. Let me do problem number 32. Log base 8, 5, log base 8, 15, log base 8, 20. So this is the same as log base 8 of 5 times 15 over 20. You can actually simplify this. So let's do that. 20 divided by 5 is 4. So this is the same as the log base 8 of 15 over 4. You can simplify this more, but maybe I'll just leave it in that form. 34. Log base 9 4x minus log base 9 x minus 3 plus log base 9 x cubed plus 1. Okay, so let's simplify this. So this is equal to log base 9 of 4x is in the numerator. I'm subtracting, so x minus 3 is in the denominator. I have plus, I'm adding, so the x cubed plus 1 will be in the numerator. And that is your answer. Let me do problem 38. 5 log base 6 of x minus 3/4 log base 6 of x plus 3 log base 6 of x. They're all log base 6 of x's. So I have 5 of them plus 3 of them is 8 of them, which I can write as 32 over 4 minus 3/4 of them, which gives you 32 over 4 of these objects minus 3 over 4 is 29 over 4 of these log base 6 of x's. And so I get log base 6 of x. Well, let's raise this up to the power of 29 over 4. And that is your answer. Yeah. Okay. Let me do problem number 60. Oh, so it says here, if log base b of 2 is 0.43 and log base b of 3.68. Evaluate the expressions. So problem 60. Log base b of 81. So in this case, what I want to do is rewrite it so that they are in terms of either log base b of 2 or log base b of 3. Well, I notice that 81 is 3 to the 4th, 3, 9, 27, 81. And so I can, by the laws of, by the properties of logarithms, I can rewrite this as 4 log base b of 3. But again, we're assuming that log base b of 3 is 0.68. And so this should equal 2.72. Okay, and so let me do problem number 62. And so I have here log base b of 4 over 32. So I can rewrite this, I can rewrite this as log base b, 32 divided by 32 divided by 4 is 8, so this is 1 over 8. But I can write 1 over 8, as 2 to the negative 3. And so this is the same as a negative 3 log base b of 2. But log base b of 2, we're assuming, is equal to, what is it, 0.43. So let's multiply that out. And so you get here a negative 1.29. Let me actually plug that into a calculator. Just check. 3 times 0.43. 1.29. Okay. Let's do problem number 64. Log base b of radical 3 halves. Well, this is the same as 1/2 log base b of 3 minus 1/2 log base b of 2, which is 1/2. Log base b of 3, what did they say it was? Sorry, log base b of 3, 68. And 2 would be, where is, oh, there it is, 43. 43. 25. I hope that's right. Let me plug this all into a calculator. Wait 1 second. 0.68 divided by 2 minus 0.43 divided by 2 is, yep, 0.125. Okay, good. Let me do, and so that finishes off section 9.6. Let me go on to section 9.7, page 585, problem 34. Log x 2.1. Solve each equation for x, give the exact solution, and a 4 decimal place approximation. And so let's rewrite this logarithmic form into an exponential form. Base 10, exponent 2.1, result x. Therefore, well, that's what x is equal to, 10 to the power 2.1. And so let's plug that into a calculator. Let me check what that is. And so 10 to the 2.1 is 125.8925412, etc. So that's your, oh, and you want it to 4 decimal places. All right. 1, 2, 3. Oh, and since 4 is less than 5, then I'll just leave it as a 5. Okay. Let me do problem number 40. ln 2x plus 5 equals 3.4. And so let's rewrite this in exponential form. And so I have the base is e, exponent is 3.4, result is 2x plus 5. Let me subtract 5 from both sides of my equation. And so e to the 3.4 minus 5 equals 2x. Divide by 2. And so I have here that x is equal to e to the 3.4 minus 5 over 2. And so x is approximately, let me plug that into my calculator, e to the 3.4 minus 5 divided by 2 is 12.48205,002. And so to 4 decimal places, this is 12.123, the fourth one. So 5 is greater than or equal to 5, so I'll round it to 1. And that is your answer. Let me do problem number 54. Approximate each logarithm to 4 decimal places. Log, base 9 of 4. By the change of base formula, this is the same as log, I'll use base 10, I guess, of 4 over log of 9. So that's the exact answer. The approximate answer is, let's do log 4 over log 9. log 4 log 9 is 0.6309297536, etc. And we want to do this to 4 decimal places. And so 1, 2, 3. Since 2 is less than or equal is less than 5, we'll just leave it at 9. And that's your answer. So that finishes off section 9.7. Let's go on to section 9.8, page 590. Problem number 6. 8 to the x minus 2 equals 12. So solve each equation, give the exact solution, approximate the solution to 4 decimal places. Okay, so let me take ln of both sides of my equation. By the laws of exponents, I can just, by the properties of logarithms, I can just bring the exponent out in front. Let me multiply the ln 8 inside the parentheses. So by distributive property, I have x ln 8 minus 2 ln 8 equals ln 12. Add 2 ln 8 to both sides of my equation. And so x ln 8 equals 2 ln 8 plus ln 12. Divide both sides of your equation by ln 8. And so x is equal to 2 ln 8 plus ln 12 all over ln 8. And that is your answer, which is approximately equal to, let's do this, 2 ln 8 ln 12 ln 8. 3, 3.1949875. So you want to do this to 4 decimal places. 3.194. So 8 is greater than or equal to, well, 5, so that 9 becomes a 10, so this 49 becomes a 50. And that's your answer. Notice in this case, we must put down the 0. That indicates that we've actually rounded to 4 decimal places. Problem 20. Log base 3x log base 3x plus 6 equals 3. Solve each equation. So let's rewrite this. By the properties of logarithms, this is the same as the log base 3 of, well, addition of logs becomes the log of their product. So let's multiply x times the x plus 6 to get x squared plus 6x. So let's change this logarithmic form into an exponential form. And so the base is 3, the exponent is 3, and the result is x squared plus 6x. And so we had the base was 3, the exponent was 3, and the result was x squared plus 6x. 3 cubed is 27. Subtract 27 from both sides of your equation. And so I get x squared plus 6x minus 27 is 0. Let's see if I can factor this. It's a monic quadratic, so let's bring down the plus. Times minus is minus. I want two whole numbers whose product is 27 and whose difference is 6. 9 and 3. Set each factor to 0 and solve for x. Subtract 9, add 3. So x equals negative 9, x equals positive 3. When x is negative 9, you'll be taking the log of a negative number. You can't take the log of a negative number, so that's wrong. But when x equals 3, you can take the log of 3 and you can take the log of 9, so that's fine. So x is equal to 3. Let me do problem 22. Log base 6 of x plus 2 minus log base 6 of x is equal to 2. So by the properties of logarithms, I have that the log base 6 of x plus 2 over x is equal to 2. Let's change this logarithmic form into an exponential form. The base is 6. The exponent is 2. The result is x plus 2 over x. 6 squared is 36. Multiply both sides of your equation by x. So 36x is equal to x plus 2. Subtract x from both sides of your equation. So 35x equals 2. Divide by 35. So x is equal to 2 over 35. And you're not dividing by 0 anywhere. So they both exist. Let me do problem number 36. Log base 2 x minus log base 2, 3x plus 5 equals 4. And so let's use the property of logarithms. So log base 2 of x over 3x plus 5 equals 4. So the base is 2, exponent is 4, result is x over 3x plus 5. 2 to the 4th is 16. Multiply both sides of your equation by 3x plus 5. And so you get 48x plus 90 is equal to, the 3x plus 5's cancel, so x. Wouldn't it be nice if I multiply correctly? 80. Let me subtract 48x from both sides of my equation. And so I have here that 80 is equal to negative 47x. Divide both sides of your equation by negative 47. So x is equal to so x is equal to negative 80 over 47. However, when you plug it back into the original, you're trying to take the log of a negative number. Now, that was the only possible solution. Therefore, this actually has no solution. Okay, 36. Let me do problem number 48. Use the formula, the compound interest formula. A equals P times the quantity 1 plus R over N, quantity to the power nt, to solve the compound interest problems. Round to the nearest tenth. No one ever rounds to the nearest tenth. They always round the nearest hundredth to the nearest penny. But we're rounding to the nearest dime, I guess. Find how long it takes a $1,500 investment to earn $200 interest if it is invested at 10% compounded semi-annually. Okay, so we'll use the formula A equals P 1 plus R over N to the NT. So first off, we want $200 interest, which means that our $1,500 investment became $1,700. We started out with $1,500. We earn 10% compounded semi-annually, so twice a year. And we want to figure out how long it takes for us to do this. So P is 1,500, A is 1,700. Our interest rate R is 10%, 0.10. And the number of times we compound per year is twice per year. So N is 2. And T is the number of years. So T is given in years, since we're having that our unit of time is year. Let's divide both sides of my equation by 1,500. And so that becomes 17 over 15 is equal to 1.05 to the 2t. Let's solve for t. So let me take, I don't care, I'll say ln of both sides of my equation. By the properties of logarithms, I can bring the 2t out in front. Let me solve for t. So let me divide both sides of my equation by 2 ln 1.05. And so I have here that t is equal to ln 17 over 15 divided by 2 ln 1.05. And that is your answer. Let's plug that into my calculator to figure out how many years that corresponds to. And so ln 17 over 15 divided by 2 ln 1.28 2667778, and we want to round to the nearest tenth. And so T is approximately 1.3 years. And that's your answer. So I guess that finishes off all of them.